Hello, everybody. My name is Ehsan-Ul Haq. I'm a PhD student at Hong Kong University of Science and Technology. Today, I'm going to talk about a method to counter human bias in crowdsourced stance detection of news articles. Political stance detection of news articles is a very common research problem across different domains, including computer science. News articles can carry a certain bias that can originate from media outlets, journalists, or reporters writing the articles. A common solution to detect the political stance that is present in the news article is through human intelligence. Human intelligence is crowdsourced through different mediums such as Amazon Mechanical Turk. However, the human intelligence may be affected by their own bias or other factors such as their comprehension of the questions being asked or the volatility in their cognition. In this paper, we contribute by showing that the self-declared stances on a given topic affect the rating for the news articles. Hence, we propose asking raters to report an article's stance relative to theirs as the article's rating, instead of article's absolute stance on the political scale. We then show that this can help us to elicit raters' nuanced stances. Through this, we can differentiate raters much better. And also, we can use this information to adjust the news article's rating. Traditionally, whenever the human intelligence is crowdsourced and they are asked for their own self-declared stances, it is done through categorical stances, such as left or right, or pro or against certain topic. If we look at this figure below, we see that there are three raters, A, B, and C, A and B being on the left, while C is on the right. There's one article shown through a yellow triangle between A and B. We can see that user A is more left to B. This is why, and we can see this through this article. This is why we propose to ask the relative stance rather than the absolute stance of the article. To further explain about our method, how we actually conduct our study, we do an experiment on Amazon Mechanical Turk users. We recruit 160 MTURK workers, evenly distributed with liberal and conservative US ideology. We then take 6 news articles on gun control that are equally distributed from left to right scale. For articles, we take the ground truths values from the Ad Fonte media rating. The table below shows the 6 articles used in this study. We then ask the MTURK raters to register through a custom web portal where each rater reports their stance as pro, neutral, or against gun control while they register. Each rater is shown 1 article per time, followed by a question to rate the article either more pro, same, or more against gun control relative to their own stance. We ask the rater to use 1, 0, or -1 to indicate if they think the article is more pro, same, or against gun control. A reason to use 1, 0, or -1 is if the rater is consistently rating an article, we will have a flip point where the rater will be placed eventually, or a rater might be aligned with one of the articles, as shown through the figure below. To show the analysis of the results, we first show that the liberal and conservative users have varied stances on the gun control within themselves. There are more pro-gun control users in the liberal group, and then there are more against gun control users in conservative groups. To show that the self-reported stance affects the rating article's rating, we use the ordinal logistic regression. We report the complete results in the paper. We have the significant results that show that the self-reported stances of the raters actually affect how they're going to rate the articles. For instance, in rating the article from a square, neutral stance to gun control makes a liberal rater's odds of giving a higher relative rating to that of a liberal rater with an against stance. We then use the average method to show the same thing. The average method is also commonly used in different studies to find the resultant rating for a given news article based on the average of all the raters. Our results show that the average rating across 3 groups, pro, neutral, and against, within each liberal and conservative category is different. With pro being the highest average compared to the neutral, and the neutral has higher average than the against gun control group. In general, liberal group has higher rating than the conservative groups. We then used this method to elicit the nuanced rater stances. We first show that the self-reported stance might not be kept correctly because the demand bias may affect the raters how they actually report the answers for this question. And also there might be possibility that the raters are actually unaware of their own true stance on a given topic. We used the 6 articles to create 13 bins across 6 articles. And one article, as we use the ratings as relative to their raters' own stances, and a rater can be put on the left, right, or at the same position as an article because of the relative rating. In total, we get 13 bins across 6 articles. We then place the news articles across left to right political scale with the raters rating all of these articles relative to their own stances. A rater stance is thus identified to be in between the stances of 2 articles of which the relative rating flips signs or share the same stance with an article. If a rater gives -1 to all articles, then his or her stance is identified to be on the extreme right side. Similarly, if the rater gives 1 to all articles, then their stance is identified to be on the extreme left. To be very consistent with the rating, we only allow at most 2 inconsistent ratings from one side to the other side. In total, we get 65 raters assigned to the bins, while the other raters do not have all the consistent ratings in their answers. The figures below show that for liberal and conservative users, we can spread those across 13 bins accordingly, the method that is defined in the paper. We can see that there is differentiation between the raters, although their categorical stance remains the same. Similarly, we also use the average method, again, to see the differences in the average across different spectrums. We only show this for 65 raters that have been assigned to the bins. In this way, we show that asking the relatives question actually can help us to differentiate the raters among themselves and also get the consistent rating of the news articles. We then show that this method can actually be used for the downstream research, not only for political stance detection of news articles, but also for other topics where the subjective bias of the rater might play a role in how they can answer the question, such as sentiment or content moderation. Similarly, this method can also be used for multi-dimensional stance detection. This method also has an applicability to the crowdsourcing platforms, where this method can be embedded into the platforms to identify the nuanced stances of the raters rather than the raters reporting their own self-declared stances on certain topic. We hope in future we can extend this work on a longitudinal study for a long-term change point detection of the raters and also on multiple topics rather than just one gun control. If you have any question, please feel free to ask. Thank you.